Hey everyone, welcome back. If you missed my introduction earlier, I'm Ronen Slavin, CTO and co-founder at SciCode. Very excited to be your host for this session today. I'm joined today by someone I'm sure you're all familiar with. And if you don't know Clint, so you probably know his excellent newsletter, TLDR Sec. I personally read it on a weekly basis and I learned a lot from it. So if you're not following the newsletter, I highly recommend you do it. In the newsletter, it distills like everything that's happened over the past week in security research, in tooling, many other topics. So again, like very highly recommended. And lots of us here at Cycode are fans of the newsletter. So again, a personal thank you to Clint from TLDRSec. Clint is also head of security research at SamGraph. So he brings a unique perspective on security threats in application security from the expensive experience that he has. So I couldn't think of anyone better discussing software supply chain attacks and social supply chain security with. So again, I'll say hello and let you introduce yourself. Welcome, Clint.
Yeah, Ronan, thanks so much for having me and the very kind introduction. Um, I think you did a great job. So I don't have anything more to say. But yeah, just I write the TLDRSec newsletter, and I'm the head of security research at SendGraph. But yeah, let's get into it.
Yeah, let's dive in. So again, the topic for us today is software supply chain attacks, and let's start with the basic. So in your perspective, what are software supply chain attacks? Why are they so complex to defend?
Hmm. So, supply chain security in general, I would say, is securing code from when it's developed all the way into production. So, I think one thing that can be confusing about that is that depending on who you ask, either the person or the company, they say supply chain security, but that can actually mean very different things. So, in my view, I would group this into a couple of buckets where one is, are we making sure that we're using up-to-date third-party dependencies that don't have known vulnerabilities. So this would be like SCA. Are we making sure that we're not using malicious dependencies, which I would say is different than SCA? Are we doing like code provenance, like doing, say, signatures to ensure that the code that was written is the same that's in test and staging and then eventually deployed into production and hasn't been modified along the way? And then finally, are we securing like CI/CD systems themselves? So are we hardening our use of, say, Jenkins or GitHub Actions or just maybe our GitHub or GitLab org settings and things like that? So I think um, supply chain security meaning so many different things like makes it kind of clear why supply chain attacks are kind of hard to defend against in that there's just kind of a lot there. And I think each part of that requires sort of a different approach and potentially different tooling, or at least some different things.
Yeah, I agree 100%. I think that kind of the reason that software supply chain attack became so wide and extensive is probably SolarWinds and all the high profile attacks that we've had over the years. We all want to help in cybersecurity, so I think everybody wanted to tie themselves into this is what I think is software supply chain attack, or this is like another flavor of software supply chain attack. So I think like that's what created what you described with all these different aspects of building software and kind of factoring it into what we call today software supply chain attacks. If we look at these high profile attacks like SolarWinds, like JumpCloud, Log4Shell, and all of that, do you think that there are things that we learned from this? Like, did the situation improve over time? Like, what is your feeling there?
Yeah, I think a couple things we learned, at least at some of these like initial high-profile breaches or attacks, is that a lot of companies were very unprepared for those. I think historically there was sort of like acknowledgement of like, yeah, this could happen, but without sort of that many big high-profile real cases of it happening. I think to some it was sort of theoretical, but I think a number of these attacks have made it clear, like, yes, this can happen, it is happening, so we need to take it a lot more seriously. So I think these attacks revealed that there's a lot of holes in how we handle these sorts of risks. And I mean, honestly, it also takes a lot of security maturity to actually handle them very well. So yeah, I think they were a wake up call to many companies.
Yeah, I agree. I think that eventually, like if we look at the software supply chain itself and what makes the software supply chain, this would usually be like technologies that are controlled by the R&D organizations, like teams that usually don't start with a security mindset or like don't base their decisions solely on security. And probably these attacks taught us that like, hey, there's a risk there. From an attacker's ROI. So obviously, spending the time on attacking a company and then for that getting to all the clients, obviously like super valuable from an attacker perspective. So it might be also something that I think contributed to that. Um, but yeah, definitely the increase over time is something that we can't ignore for. Um, so I guess like
Yeah,
we've yeah, sorry, go ahead.
sorry. I was just going to say one hypothesis I have about why we're seeing a lot more of it now than we used to is that just there were a lot of other attacks that were much easier, right? Attackers have timelines and budgets and they have specific goals they want to accomplish. And maybe in the past it
Yeah,
was just easier to do other things. And then we sort of got better at certain other things. Maybe like application security got a little bit better, like OS top 10 and other things. Cool, we're more aware of these sort of web style attacks. And then they're like, okay, well, what's the next easiest thing we can do? It's like, well, no one's really applied much thought to supply chain security. Cool, let's do that. That's easy. So it's easy to think
yeah.
like, oh, everything's on fire and like everything's horrible, but it's it's easy to think that, but like, well, maybe it always was that way. We just weren't paying attention to it until recently. So I think that's a useful mindset to keep in mind.
Yeah, it's a great point. Like, I mean, eventually attackers are business also, and they want to do what pays off the most from their perspective. So, if application security is the easiest place to get into, they'll address that. So that I assume like this will be like 0 days and all kinds of 1 days that were exploited. We got better at doing that. They went like to the adjacent area where they identify the most hole and the most places they can take advantage of. I think it's a great way of looking at this. So I guess this leads us to kind of the next question. And obviously, we've had all of this in the past couple of years. Do you think today we are better prepared, or situation is worse?
Yeah, that's a good question. I feel like, yes, overall we are better prepared. I think there are fewer unknown unknowns. Like you were saying before about how, when people were just figuring things out, and then there were lots of like different names for things or people like coming at the problem different ways. I think uh, it's still a very like nascent industry and problem, but I think that over time we are understanding a little bit better what the landscape looks like in terms of these are the types of classes of issues we should make sure to protect against. And yeah, I think tooling, products, things like that, I think they're definitely coming along. I believe it's still early stages, but I think that we've made some promising progress so far.
Yeah, I agree. I think that eventually, like from the way that I sense, there's all these emerging standards and trends that are being formed. They're not easy to digest, especially like if it's not your day job to work on for supply chain security or the relevant space. But they are a good indicator. I think that we're getting somewhere that will be much better for the industry and for everyone else. Right now, it's a bit complicated situation. Like I agree that there's all this new stuff and everything needs to. We need to dive into each of the standards, understand them, how they apply to us, how it's relevant to how I'm building code. Like it's all um, maybe a bit overwhelming, but that's a step in the right
Mm-hmm.
direction. Cool.
Mm-hmm.
So maybe following down this path, are there any potential policy solutions or regulatory frameworks that you recommend our audience to be exploring or looking at in order to kind of understand this landscape better and prepare themselves better for these types of things?
Hmm. To be honest, I would say I'm not an expert in the sort of policy or regulatory side of things. But one thing that I think is interesting to think about is I would argue that historically, security hasn't really influenced stock prices for companies. Like if you think of very massive breaches, yeah, maybe some companies have paid a fine and their stock has taken a hit in the short term, maybe over a couple of months. But I think overall, there's been relatively few companies that have gone out of business due to a breach. There's been a couple maybe that had like a catastrophic ransomware incident, but it's actually very few of them. So I think that there is certainly some value in having some regulatory pressure to at least do the security basics, because there's not necessarily market pressure for companies to do security well, because consumers, at least from what I've seen, don't tend to choose based on security. So I think that like regulation or things that are encouraging companies to do the right thing, even if it's not the most profitable thing, which would be to ship more features faster. I think that could be a good thing if done well. And I think also something to keep in mind is that there's different parties involved here that have different um, interests and goals. So, for example, open source developers are like, hey, this is my free time. I just want to make something cool for my needs or to show my friends. And then you have enterprises using that software and basically trying, in effect, they're putting more obligations onto the open source developer in terms of like, hey, someone reported this CVE in your library, please fix it, or please have all these sort of strong security properties of this code. And I could see the developer's argument to say like, hey man, like I'm doing this for free and you're not paying me, so like why are you making me do all this work for you? At the same time, obviously we want the ecosystem to be secure. So I think any policy solutions or regulations, I would hope would take into consideration how do we make sure that the open source community still flourishes because it provides so much value to everyone, but also like ideally has some nice security properties and there's not like a tragedy of the commons. Ultimately, I think it would be nice for companies to fund the open source software that they use, hopefully, so that would incentivize uh, building with security in mind rather than strictly just features. But I think it's a complex situation, but that's some thoughts.
Yeah. No, I think it's a cool view because like eventually you can find developers, right? Like developers are developing in the way that everybody's developing. There isn't a company that's not using open source. We want to encourage that. We don't want to, go against the stream or something like that. And I think if the regulators kind of understand that like our role here could be like incentivizing the industry to be more secure by financing remediation or having projects that effectively remediate like common open source projects or things like that, like this would be the kind of the right way for them to be involved and adopt kind of the trends in the market and not like go against them or something like that. um, I think that if I look at companies that had massive breaches, I think a lot of time they're measured at how they respond. So it's not necessarily the fact that you had an incident. It's also like how did you respond to it? Were you transparent in letting everybody know? Did you have the adequate controls that were supposed to prevent it and they failed, or maybe you didn't, or did you take security seriously enough? And I think like that's kind of the areas that I would like expect to see also the regulators maybe chime in and kind of guide decision makers on what would be kind of expected from them and make sure that um, we're all more secure by sharing like what we experience and learning from each other, um, then moving everybody to kind of a more secure ecosystem.
Yeah, I think that's a really great point. Like if you are a company that has an incident or breach, I think that is also a great opportunity to build trust with the community in terms of how transparent are you with, this is what happened, how detailed are you with, they got in like this way on this date, and this is exactly how they move laterally, and like I think the depth and rigor that a company shares, like what happened, is an opportunity to build trust. Like when I see a company that has a very detailed timeline and they're very transparent about it, that kind of makes me trust them more. So I think other people feel that way too.
Yeah, I agree 100%. Yeah, completely. Cool. So moving on, like in previous quotes, you reference a famous quote that says software is eating the world. Obviously, we see software in cars, in power logistics, global distribution. Like everybody's running on code these days. Um, what does our increasing software dependency means from your perspective to security teams, and kind of how does it shift things?
Hmm. I think one thing that sticks out to me with the increasing role of software everywhere is that cybersecurity is important, and we have an important role in both our company as well as in society as a whole. When you think about like the power grid or water or obviously e-commerce, but even groceries and things that fundamentally are running modern human society, pretty much all of it is touched by software. Probably not even just once, but at like many different steps in terms of um, the logistics in terms of what's going where, making sure that I don't know produce is like fresh and doesn't go bad. Like I think
Yeah,
obviously I think as security professionals we already put a lot of pressure on ourselves to do well and keep systems secure. But I think it is also useful zooming out to think like, oh, I'm actually helping secure the systems that my family uses or my partner uses or like my parents use. So I think that this is exciting place to be in terms of having a big positive impact on the world. Um, and then I'd say the other thing about that is because of the scale of the challenge, I think we need to also scale ourselves with software via automation tooling, things like that. And some things we can rely on sort of manual one-off approaches, but ultimately, I think to really do a good job, we need to think about how do we put security into frameworks and libraries, and yeah, scale our security efforts better than linearly with person time. Because there's currently, unfortunately, not enough people with excellent cybersecurity expertise, so we need to scale other ways. But yeah, so impactful and then scaling with software.
yeah. So it actually like takes me to kind of the follow up question. So you mentioned scaling, and kind of what we see here is that the attack surface for software supply chain is something that keeps growing. Like there's more and more tools used. Um, like what does the exponentially growing attack surface mean for you, and like how would you recommend our audience to secure it?
Hmm. Yeah, that's a good question. I think in general for supply chain security or other domains within your company, I think it's important to think scalably. Like, how do we solve this class of problems rather than sort of this one-off case? Similarly, like if you're at a tech company, you probably are not going to build new product features that require like linearly more work for new customers, right? Because that's not a good model, right? You don't want to be like, we have 10 times as many customers tomorrow. Now we need 10 times as many support engineers. Like you can do that, but not for long because it's just going to fall over. So I think security team should similarly think the same way in terms of, we have this risk we're trying to mitigate. What's an effective way to do that? And how can we do that at a minimal amount of toil for the security team? At every company I've ever spoken with, the developers outnumber the security team by 100 to 1, 200 to 1, maybe more. So we can't really have solutions that effectively deal with risks if the process requires like scaling linearly with the development team. Ultimately, we need sort of like better than linear wins with sort of the things we build. Um, yeah, and I think that if you think about it cleverly in terms of like, okay, how do we like systematically reduce or even eliminate this risk from happening in the first place? I think that that's a way to get these sort of compounding wins, even if the attack surface is large. Um, but yeah, I think
Yeah,
applying some systems thinking and yeah, ultimately, yeah, building secure defaults into frameworks, ideally making security happen transparently around developers such that it sort of just happens and they don't have to worry about it, I think is what I've seen done very successfully at a number of companies.
yeah. I think that's great insight. And if I try to kind of maybe like I don't know summarize or reiterate it, so or kind of the way that we see it. So I agree completely. Like I think you start with one challenge that you want to solve. Each challenge that I think is in our domain right now is has like two aspects. There's like the technical data aspect. So there's like all this mess that you need to fix in the challenge that you decided to address. And there's how do I keep it from growing back up moving forward. Then if you take each issue and look at it from these two perspectives, that's kind of that will be your way to actually like drive remediation and eventually move down to the next use case, right? So like you recommended like start with something maybe more narrow that you want to solve, figure out like what's the processes in the organization. Usually you would need to communicate with other stakeholders, with other departments, figure out how you close the tag that, and moving forward get less and less of these issues, then move to the next one. Like that's kind of what I took from your guidance.
Yeah, yeah, I totally agree with that. I was actually I did like an interview with my friend Dev, who runs security at Figma, and he called that ratcheting, where basically you have some issue that you're trying to tackle, and then you're like, okay, how do we, um, you know, if there's something that you're trying to do that's new, probably you have this backlog of like, yeah, existing code probably has a bunch of these problems, but first, how do we maybe prevent new issues of this type from entering our code or entering our environment? So it's like we can make uh, like the future better because we're not introducing new things, and then we have this backlog of things that then we can go back and fix once that we make sure that we're not sort of like introducing new issues. Yeah, I'm basically just reframing and reiterating what you said, but I just wanted to give like a big plus one that I've heard from a bunch of companies that they tackle it exactly that way, and they found that very effective. So yeah, I would, big plus one on that.
Very cool. Um, okay, so do you think that there are things that we are getting right in our fight against software supply chain attacks? Like, are there things that we are doing well in your perspective?
Yeah, I think there's a couple of things. For example, I think that we are treating it seriously now and we're investing in tooling to address it, which is good. I think that's a shift from, 5, 7 years ago. There's also been a lot of open source efforts or efforts from the open source community in terms of the OpenSSF or CISA or CNCF. There's a bunch of organizations that I think are doing good work. I think Google or maybe some other companies had some sort of fund where they were like basically funding people to help work on securing open source software, whether that's like
Yeah.
fixing bugs, doing security reviews, things like that. So yeah, I think there's definitely a lot of promising things happening, but I think it's still early stages. But I think we're headed in a good direction.
And like if we try to look at the other side, so what are the areas that you think we should improve or we haven't solved yet? What would that be?
Yeah, I mean, a number of things, but I think one thing you called out earlier, I would agree with, that right now it's kind of complex, I think, to do supply chain security well. So I think what would be nice is some sort of holistic solution that combines all the different parts and just makes it really easy to adopt. Like if there was some templates or frameworks or things that, let's say you're like a new company or an existing company spinning up a new project, like how do you just like what are like the easy buttons or what are like the check boxes that you're just like, cool, I'm just going to do these one or two things and then boom, I've done like 80, 90% of the work immediately. I think now it still takes a fair amount of like domain expertise in both security and like supply chain security particularly to do all the things right. So I think over time if we can make that easier, that would be better because right now I think it's too hard.
I love it. So make it easier and accessible. Yeah, I agree. Like I think that's the kind of the key missing piece that we have today. So I'll move to probably the last questions. I know we're almost at our time. So let's look at the future. If we try to think of the future of secure software supply chain and the secure the future of secure software. So like can we envision a future where software trustworthiness is built and constantly verified? Like how do you see maybe the coming years?
Hmm. Yeah, I think in general, insecurity and also supply chain security, I think as easy and obvious as we can make it as possible is strictly a good thing. Ideally, um, requiring not that much security domain expertise. Like, so I guess, for example, I could imagine, you're spinning up a new GitHub repo and you're like, oh, I'm going to build a web app in this language or framework. And I don't know, maybe it comes with a bunch of templates. They're like, okay, cool. You're going to want this library to handle parsing XML securely. You're going to want to include this thing for handling CSRF and output encoding, and just like all the different building blocks are sort of nicely pre-assembled for you. I think there's some good stuff in this direction already. Like there's the OpenSSF security scorecard, which can show you some security relevant information of open source projects. I think so. Salsa, which is or SLSA, which is about sort of high integrity build environments and sort of like securing that build process. I think there's a GitHub action that you can just fork that does a lot of it for you automatically. So I think there's a bunch of work being done for how do we have standard best practices that you can easily adopt that are like free and open source, or various templates or various tooling. So I think that the future to me is investing more in those things and making it easier and more cost effective for anyone, regardless of their security knowledge or domain expertise, to do things securely. So, yeah, I think there's a lot of good work being done in this space. So, just making it more easily and widely accessible, and just making it clear what the right thing to do is, I think is key, even if you're not an expert.
Yeah, I completely agree. Like I'm sure we'll see much more advancements in these areas in the near future, and hopefully it will take everyone to a much safer state. Obviously, we all use software all the time. Um, so thanks everyone for joining our session. This is our time, and a special thanks, obviously, to Clint for your time today, and again, like all the amazing work that you're constantly doing, educating the community on the recent trends and everything that's going on. So again, like thank you so much. Um, I'm handing back over to Shona, who will take us on to our closing keynote. You don't want to miss this one, so don't go anywhere.